It's my very great pleasure to introduce to you Professor Brian Josephson, Nobel laureate and Professor of Physics at the University of Cambridge in England. And I think also in the title of his presentation we can see a reflection of the Age of Enlightenment. I'm sure we can anticipate a beautiful blending of subjectivity and objectivity just from the title of his presentation, which is Intelligence and Physics. Professor Josephson.
Well, in this talk I want to say something about some ideas which have come out of some concepts which Maharishi has introduced and which Dr. Domash has elaborated. And this is a question as to whether one can find a basic connection between intelligence and physics. Now, as you're probably aware, physics has gradually extended to cover a steadily increasing range of phenomena, such as originally the laws of mechanics, and then things like electromagnetism, the theory of electric and magnetic fields, and then to phenomena in atoms and the solid state, and astronomy and so on. But it hasn't really been the attention very much of physicists so far, and I think the reason is that it's been supposed that intelligence is just a thing that happens eventually because of a result of evolution, but is not contained within physics. But it is starting to look as if this may not be the case, that one may be able to see how intelligence is a basic part of physics, and I want to sketch some of these arguments in my talk. Now, to introduce the subject, I'd like to talk to give some examples of intelligent behavior to fix our ideas. So let's take as one example out of an animal searching for food, which is obviously a sign of intelligence. If we just took a piece of metal or something, we wouldn't expect it to go searching for food. But we have to look a little carefully at this and see exactly what intelligent behavior consists of. And the main point I want to make at this point is that intelligence can be equated partly with non-random behavior. And the behavior of an animal seeking food is non-random in two respects. First of all, the perhaps less immediately obvious one is that in fact the thing it chooses to search for is food rather than something which is not useful to it. And so it is selective in what it searches for. It doesn't just go for any random object, but chooses food. And the second thing is the method by which it gets food. It doesn't randomly walk about all over the place, at least if it has some higher form of intelligence rather than some very low kind. It goes in a very directed way. It moves in the right direction. It moves around obstacles, and so on. And so we can say that we have a very non-random kind of behavior occurring in the means by which it gets to the food as well as in its choice of goal. So this non-randomness is a thing which I'll be talking about as an important feature of intelligent systems. But before I want to go on to that, I want to draw to your attention the point about I've said previously about the nature of what it does, the fact that it gets to the food, but we must also consider the result of getting the food, and the result is, of course, that it is able to sustain its life. It needs to get food in order to go on living. And we see that, therefore, a basic property of intelligent systems is that they're doing things which maintain their existence and hence maintain a rather unlikely state of affairs. Like it's rather unlikely we should find an animal existing, but at least the animal helps to make this unlikely state of affairs continue by taking food. And so this is really the way evolution produces intelligent systems. But the key point is that it's a situation which we might think is a priori extremely unlikely that this particular collection of cells should exist and happen to give rise to behavior like being able to walk and see and so on. But this a priori unlikely state of affairs becomes slightly unlikely when we consider that it's got intelligence, because the intelligence supports particular unlikely forms of existence. So in fact we can start to see the possibility of a deviation from what we'd expect from thermodynamics, that nature in fact tends to be non-random as a result of evolution. However, the next point I want to make is that the behavior I've talked about so far, and which one might imagine to be confined to living systems, is in fact not confined to living systems. We can in fact produce quite simple mechanisms which lead to this kind of goal-seeking behavior. And so in fact the question gets pushed back one step as to why these particular mechanisms should come into existence. But let me anyway illustrate the point that some fairly simple kind of mechanism can give rise to goal-seeking behavior. I'm going to illustrate this point by talking in terms of a guided missile which can home in on a target. Let me now sketch up roughly how a guided missile system works. It has a target, and here's the missile itself. And the way the missile homes in on the target is that it has receptors that may, for example, detect heat emitted by the target. So it's got some kind of sensors which pick up the information, and so it knows the direction of the target. And the way it gets to the target is by using what's known as feedback. If it's going in the wrong direction, for example, if it sees the target is to the right, it steers slightly and moves to the right. If the target goes to the left, it steers slightly to go to the left. And so it will therefore automatically, whatever way it started off and whatever disturbances happen to throw it off course, it will get to its target. And this, of course, doesn't require living systems. It's just ordinary electrical circuits are needed to make these connections. So, however, it's convenient to regard this as intelligent behavior, even though it's not a living system. And the conclusion we draw from it is that essentially the design must be right in terms of the relevant components being connected up to each other. And so intelligent systems can arise quite naturally in this way. And evolution tends to produce things which have got the right kind of connections in living systems. For example, a system which causes your eyes to move towards an object you want to look at has this kind of circuitry built in.